All right. So before we talk about your questions, and we can go up to 5 p.m. as I promised earlier. But if we finish earlier, we'll finish earlier. We'll see. I want to draw your guys' attention. I just sent some early announcement. I mean earlier today, just to remind you about the exam. Some details. I'll go over that very quickly with you. Right. So if you go to e-class and go under course announcement, and then there is one there. The first one here is just about the lecture site. If you go there, I kind of combine all the slides, all the iPad notes, and also all the lecture recording, just for the a little bit easier for you to review. You can just go to the top of the lecture site. You can see all the links, right? So that one there, if you find it useful, feel free. And I want to talk about this one very quickly. Okay, so this one here, nothing surprising. It's really something just standard. I just want to go over that quickly so that you guys are aware of what you should really watch out for, for the exam. All right, so please make sure you bring enough pen and pencil and eraser. You will not be able to share, with your neighbor. Please bring enough pen, bring enough pencil. Also make sure you bring eraser. You definitely need it. Okay. And also, please make sure when you write, only either in black or in blue. Okay, we don't accept any answer in other colors like a red, orange, purple, green, because we're gonna grade by our hands. It's gonna be very difficult for us to recognize your answers if that's not either in black or blue. So please make sure you bring the enough pens and or pencil. Pencil is definitely fine, but if you bring pens, make sure that's the right color. All right, so it's 3 hours and then close book. And in case you're wondering, there'll be no data sheets. That's the same. I kind of mentioned that in the class. And you'll receive the question booklet and also answer booklet. So you're gonna put all your information there. And I'll also remind you during the exam. All right, let's see. And you gotta make sure you return both at the end of the exam. Okay. And make sure anything you just be sure that just make sure you remember anything you write on the question booklet. They will not be graded. Okay, so we only grade anything you write on the answer booklet. Okay, so be sure. And make sure also when you answer the questions, you don't really have to put down the answer, like in sequence. But when you actually, you gotta leave some empty space for any question you want to temporarily skip. Right, so these 3 bullet point here, that says that pretty clearly. Okay, but just easier for us to grade as well, just more efficient. There will be some multiple choice questions, only single answer. Okay, and there will be mostly written question there, as I said before. That's just about the color for the answer as before, and then please try to write legibly, so easier for us to see your thoughts. It'll be easier for us to grade. Or maybe even easier, if a partial mark should be awarded. And on the answer booklet, it's not really for sketching purpose. We only grade whatever you write on the answer booklet. The booklet that you receive for the questions, they will include about 4 pages for the sketch purpose. So you got enough sketch paper. Okay, so you make sure you don't really sketch on the answer booklet. So here are simply some tips about the exam. That's kind of the general tips I can offer. May not work for you guys individually, but take a look. Okay, I don't need to waste your time reading it off. Take a look. Okay, it might help. All right, for the rules, you don't need your mobile phone, so please make sure you put it in your bag, put it underneath the table in the exam center, and then stationery, I just mentioned. And make sure you bring a physical ID, since your phone will be actually stored in your bag, so make sure you got ID. So these are all acceptable, right? Also, if you want to bring water bottle or snack, whatever you like, that's fine. All right, so that's something I want you guys to be aware. But you can read it through again before Sunday. That can save you some time. You will see exactly the same cover page on the first page on Sunday, so that can save you some time on reading. Okay, I think that'll be it. So now I can start taking you guys' questions. All right, you can ask me anything. You can ask me from the slides, from the notes. If you want me to go over some example questions for the exam, I mean the one I posted, that's also fine. Anything. But I would suggest maybe we can start with something that might be to clarify, some topics in general. But whatever you like.
You said you cannot declare inherited attributes, but when I tried it, there
Mm-hmm.
was no compilation error. So you said there would be a compilation error if I didn't get one, and I'm kind of confused.
You mean cannot redeclare attributes?
Yeah, did I redeclare?
Okay, so this one is a bit trickier. So are you trying to redeclare like a private attributes?
No, they're both public.
You should
But
redeclare public attributes.
I redeclared a no modifier attribute.
So you're saying that you got some parent class and subclass, and then you should redeclare some like no modifier attributes.
Yeah.
I think yeah we can I can double check over here, but I think let's now start with the method. I think method is something that's even more important for dynamic binding. So if you, let's say in the case of the subclass, you can definitely redeclare the methods, but that's something you're gonna see about overriding, right? But let's now take a look maybe about the attributes that you're talking about. Okay, we can give it a try. Okay, we got class A here. And we got class B here. Okay, we can try different combinations. Let's take a look. For example, let's say here, let's say, of course, we're going to make sure B extends A. Okay, A here, and then let's say integer I. Okay, and then over here, B extends A. That's kind of scenario you're talking about, right?
Yeah.
Okay, that's interesting. Okay, so let me see. If that's the case, I'm just curious about if I try to take a look at this. Okay, apparently that allows you. However, on the other hand, if I try, for example, okay, interesting. Okay, let's say this. I would say this is kind of feature I'm not aware of, for Java, but since I'm not aware of, at least for this one here, it's not really covered in the actual exam. I'm just talking about redeclaring attributes. But for methods, what we discuss in the class is still valid. But this one here, we can experiment very quickly. Let's take a few minutes. Okay, so let's say, for example, if I do over here integer I, and also if I redeclare this to be integer I here as well, public B over here, let's say integer I over here, this the I is I over here, all right, and then it could be that Java just keep a separate copies over here. When we visualize the objects over there. So let's say at the runtime, when you visualize A, it's definitely going to have I for sure. And then when you visualize B over here, it's still going to have I. So what I can do is, let me do a tester over here. So let's say we have a tester here, just make it over here. So let's say we are trying to create objects here. Let's say object B, new B over here, and the B here. That one is gonna take some integer 23 over here. It's interesting. Okay, let me do two separate things. First of all, let me do this one here. If I try to debug over here, okay, so now now it's right before the creation, so we don't have the OB here just yet. But if I try to do this one over here, you can see here under OB, we actually got, okay, interesting. All right. You know what? This is interesting. That's something new to me. But as I said, it's good for our information. For this clarification specifically, it's not on the exam. Okay, in case you're worried about, right? That could be something I can maybe clarify further. Maybe the next time I teach 2030. Okay. So you can see here in the superclass A, we have a variable I over here. And that one there is basically over here, the I here. And then we got the subclass B here, which, as you said, we kind of redeclare I. So, but the way Java treat it is, it's not really redeclaring. Because when we say redeclaring, we are really say what used to be I, we are still keeping the same I. But it's not the case anymore. As you can see, we got two separate copies over here. To me, it's very confusing. Because you can see for the same object here, we got I here, we got I here. So this I here is this I over here that we have initialized to be 23. If you remember, we initialized that to be 23. On the other hand, the I that we actually inherit from the parent class over here, we never try to initialize it. So that's why it remained to be 0. Pretty confusing, but apparently Java allows that. Yeah. Yeah, you know, I think it's a nice question here, but it's a pretty confusing aspect of Java, I would say, because in this way, when you look at the I here and I here, for now, we kind of, this program is still simple. We can see which I is from. One is from subclass, the other one is from superclass. But as we develop the program further, and we to the breakpoint and debugger, it will be becoming very increasingly complicated for us to tell which one is for which. So it's allowed, but very confusing. Yeah. All right. All right, I can see. Oh, yeah, question?
Just quick question. For the exam, right? Is it similar to lectures where we assume like no modifiers on our methods and attributes?
So I would say for the exam, it would be very clear if I show you any fragment of code. For example, if you see a fragment of code, the method there has no modifier, then there's no modifier.
Okay, thank you.
Yes, yeah. All right, any others? I can see from Zach in the chat. Can I go over question 6 from written test 2? Okay, I can definitely go to written test 2 there, but it may not be question 6 because somehow it's randomized, but you can tell me which question it is. Okay, let's now do that. So written test 2. Okay, let's now take a look. Give me one moment. I'll go written test 2 over here, and then let's say start the attempt. Zach, can you tell me which one is question 6 for you?
Yeah, it's this one.
This one here?
Keep on going.
Okay. Yeah. Okay, maybe not this one here. You know what? Let me maybe go all the way until the end so we can also see the answer as well. Okay, give me one moment. Finish the attempt. Then I will be able to see the answer as well. Okay, now this one here. Is it this one?
No.
No, okay. This one?
No.
Okay.
None of these here.
Now these, okay.
Yeah, it's this one right here.
This one here, okay. Do you have a specific question about the which option or just everything?
Yeah, just everything, like how it works. Yeah, what to look out for.
Okay, sure. So let's read it together. So here we are basically trying to test the method M, and we are making the following assumption about the expected behavior for the method. That means anything that's outside the expectation, we should fail the test, basically. Okay. So now we say that the very first time you actually call M, then there should be no exception, right? That means if there's any exception occurring for the very first call to N, that should be like a failing the test. Okay. On the other hand, if you're calling the same method for the second time, then now the expectation kind of flip. So that means here we want the exception to be occur as expected. If the exception does not occur, then that means the test should really fail. All right. So what you can really somehow sketch on your paper right away. Okay, you know what? How about this? Let me just get this fragment over here and then make some notes for you, and then we can go over the options. Give me one moment. Okay, right here. Okay, so something you can note to yourself right away is this. So you can see, okay, based on this particular exception over here, so that means if there is some exception, that means it should fail. And if there's no exception, that means it should pass, as far as the first call is concerned. And then when we get to the second call, and now we are being more specific, some exception. Okay, so this one means if some exception occur, that means you should pass. Otherwise, and when I say otherwise here, you can think about there are two cases. Either there is no exception, or if there is exception but it's not really some exception, it could be, for example, array index out of bound exception, right? You can still consider as fail. Other than some exception here, that should be failing. All right, so that's kind of something you can sketch right away, right? Once you see the question, okay, about the expectation, because every time you want to decide whether a task should really pass or fail, you should want to know what the expectation is. All right, so let's now go back to the question itself. All right, let me just put this Eclipse away over here. Okay, over here. All right, so here we basically gotta decide which one is appropriate. How about, I mean, the question itself is asking for not appropriate, but let me focus on the appropriate ones, okay, one by one. And here we have some assumption over here. And notice that this one here is only about the console tester, right? Console tester means if we're using system.out.println line, in which case we are saying that if the test prints nothing, then that means a pass. If the test actually prints out fail, then it should fail. Okay, and also it's also very important if you look back to your, let's say, the JUnit test lecture over there. I think that there was one exercise that we did in class where if you actually got some failure happening already in the console tester, you want to make sure you kind of fail the test right away without going any further, because as soon as the test actually fail, the execution flow should be interrupted right away. You should not really proceed with the rest of the test code. Right? That's another implicit criterion for console tester as well, which we discussed in the class. Right? All right, let's now take a look. For example, let's say for option number 1, so this is a JUnit test, right? So what we're gonna make sure is, well, here it is saying that if the first call has some exception thrown, then we'll go to catch some exception. You can see that one is already inappropriate, right? So can you see that logic there? Okay, let me just get this one here and then show to you. And then I'll put it here. Okay, for this one here, for example. Okay, for this one here, let's say, for example, let's say object n, in case some exception occur.
Excuse me, I'm sorry to interrupt.
Yeah.
Will this be posted as a video later on? I'm unfortunately not able to stay here for too long.
That's okay. This will be posted. Yes.
Okay, thank you.
All right, sounds good. All right, some exception over here. All right, so some exception here. Let's say this one should be unexpected, right? Let's note it right away, because according to what we noted earlier, so if you got any exception, including some exception, it should be a failure. So this is unexpected. Right, you can see here is simply do nothing, and do nothing according to JUnits is actually like a pass. So we got some contradiction over here. So we actually got unexpected behavior, but it's actually a pass for the test. So that's why this is inappropriate. All right, so that's the first one. That's the first option. All right. Okay. So Zach, are you okay with the first option here?
Could you just explain what you meant by do nothing and pass
Sure,
this
no
one
problem.
more time? Yeah.
Yeah. So let me also show you one page. Yeah. So this is also important. I think the most important where you want to think about whether pass or fail. So if you go to that JUnit test lecture, let me show you the page you should look at. Okay, let me see. Not here. There we go. Almost there. Not here. Ah, there we go. Okay. So you can see here is the definition for whether a JUnit test should be passing or failing, right? So basically, it will be considered as a success for the JUnit test if neither assertion failure nor exception occur, right? So you can see over here, let's say how the execution flow goes. If unexpectedly, the first call to the method actually throws on some exception, that's going to be caught in this catch block. In which case, it's going to execute what's inside the catch block. But now the catch block has nothing here. That means we're just going to execute nothing, which means no failure is going to, no exception is going to occur in this catch block. So overall, there's no exception or assertion failure happening for this test. So that's why this test here will be considered as passing. Does it make sense? Okay,
Yeah.
good. Yeah. So that's a very important principle, actually. Okay, let's now move on to the second option. All right. All right, there's the first option here, and that's the second option. All right. So here, okay, this one here, let's now also take a look. Okay, this one here got some nested, try and catch, and okay, this one here. Okay, let me paste it here. Oh, you know what? I may not have enough space, so why don't we put it in another page? Okay. Okay, over here. All right, so what you can think about is we actually got like a nested try and catch. It's like a nested loop or nested if statement, a little bit like that. So think about, let's say, the outer one, okay, make it thinner, the try and catch over here. The outer one correspond to this catch over here, and the inner one, the try here, correspond to the catch over here. Or even more explicitly, you can think about the try and catch over here, consider that as a big block that's going to be executed first before we can move on to, for example, whatever that's after this try and catch block. And similarly, we also got this try and catch over here as a big block. Okay, that's one way to see it. All right. Oh, actually, let me just only box it over here. Right here. Okay, so also good. And then let's now analyze this. Okay. So as you can see, this is the first call. Okay. So this is the first call. Let's think about what we expect. Expect no exception. No exception. And if you think about it, let's say if exception does not occur, in which case we are simply going to proceed to the next big block. In which case, no assertion failure or no fail has been triggered by this one here. On the other hand, if some exception has been thrown from this line over here, this method call, we are going to bypass this block over here, and then the exception is going to be caught right over here. In that case, it's actually going to fail. Right? So this is so far the good behavior for the test. Okay. So let me say this. So you can think about here. If exception occur, it will be caught, and the fail will be printed. Right? I'm talking about exactly this branch over here. On the other hand, if the my exception not occurred, that will be the expected behavior. You will simply proceed with the normal flow of execution without, like interrupting the behavior, right? Interrupting the flow. Proceed with the normal flow. All right, so far as the very first method call is concerned, we are good. All right.
Professor, I just had a question.
Yeah, go ahead.
So just because you know how when we catch the exception, we like print out the fail, but we talked about how in class, like just printing it to the console isn't really sufficient to like.
Yeah, that's true. So I think in general, that's right. If you really consider, let's say, console tester and JUnit tester. So console tester in general is simply not as good as the JUnit test. But I think this one over here somehow can simulate what can be done by the JUnit test. If you think about the I think one of the option there is about the correct option for JUnit test. That's something when we get there, I can mention that again. But that what's important is for the test, you want to make sure as soon as the failure actually occur, you want to break the execution flow right away and fail the test and without proceeding any further. So that one there is going to be more complicated to ensure than in the console tester. For example, in this case, without like a nested try and catch, you wouldn't be able to achieve it. You can somehow simulate what you're doing in the JUnit test, but it's difficult to write. It's not totally impossible, but just in general, if you don't really have the nested try and catch, you can easily write into some inappropriate console tester. I think some of the option we'll see later as well. Does it somehow answer the question or not quite?
It does, but I guess I'm just wondering like for the very last line, the system.out.print
Yep.
line. Does it not make sense to just write a fail there instead? Isn't there?
I see what you mean. So here, when we talk about console tester over here, so since we call it console tester, we want to do everything on the console. So we're assuming that somebody is going to maybe only run this main method just for this block of code. And then they're just going to run this and then decide from the console output whether it should be a pass or failure from the test. That's what we're assuming. Yeah. But apparently that's not very good. But because, let's put it in a little bit more general context. What if you want to have maybe 10 test cases? In which case, are you going to print out maybe different pass and fail several times? It's not going to be very easy to manage. So the JUnit test, the framework, is going to be much nicer way to do things. So here we are only talking about a single test, only a single one. Okay, good. No problem. Okay, let's continue very quickly. So we just discussed about the very first method call, and let's say if we are able to we are able to receive what's expected from the first method, which means no exception, we're gonna proceed to the second one. So we are kind of wrapping them in different contexts for the try and catch. So now for this inner try and catch block, so now we're going to have this one here, right? That's the second one. So think about this is the second call. So here, we expect some exception. We do expect that. All right, so let's say if somehow we are able to get interrupted by the flow and get to some exception, that means the expectation is met. In that case, we simply don't print anything, and that's the definition for pass. If you, that's what the question mentioned. On the other hand, if you actually go ahead into the next line, as we said in the class, if you're able to proceed to the next line, that means nothing has happened, including the some exception that's expected, right? So if you're able to reach this line here, reaching this line means the expected some exception did not occur. In which case we are printing fail, right? So think about the first method call and the second method call. For each one of them, you got to think about, is the pass handled properly? Is the fail handled properly? And also for the second call, is the pass handled properly? Is the fail handled properly? So we just talk about each of the 4 cases. So they are all handled properly. So that's why this is a good one, appropriate. Okay. So this is appropriate. All right. Zach, are you okay with the second option here?
Yeah, that makes sense.
Okay, very good. Okay, let's now just continue. Okay, just to see. And the third option here is also a JUnit test. Okay, so over here, let's see here. So we try to make the very first method call. So we are saying that, so this one is actually not right. Okay, we can see right away. Okay, again, let me just show you us. Since now we are talking about this question here, let's make it properly. Okay, let's talk about it properly. Okay, this one here. Let me just paste it and I'll talk about that one. Okay, there we go. Okay, number 3 over here. All right. So if you think about this one here, it's a JUnit tester. You can see that. So now the very first method call. All right. You can see if some exception occur unexpectedly. If some exception occur unexpectedly. In that way, it's going to be caught, but here there's no fail. That's inappropriate, right? Because our assumption is for the very first method call, there should not be any exception. But if some exception really occur and get caught, it should fail, but it didn't fail. So that's why this is inappropriate. All right, hopefully that makes sense. Okay, feel free to follow up just in case you got a question. But let's now take a look at number 4. Okay, so number 4 here. So this is a console tester. All right, so for this one here, okay, this one here also I got asked to clarify also a few times, but I'll explain this one as well. This one here looks reasonable, but I can tell you what the problem is. The problem really is, as soon as the first failure occurred in the test, you should really interrupt the flow right away. Okay, so let's say this. So for this option here, you can try, let me just go for the very first try block over here. Okay, let's talk about just one single case. Okay, let's say this method here, the very first call, let's say that one there throws the exception unexpectedly. The some exception. So some exception unexpected. In that way, we're going to fail. So far, so good. But the problem is, remember another criteria I just mentioned. For a test to be appropriate, as soon as you see the first failure, the rest of the test method should not be continued. The flow should be interrupted. That's exactly what's going to happen when we have a fail in the JUnit test. So you want to make sure the console tester is going to somehow simulate the behavior for JUnit test. Okay, I'm going to write this down. As soon as a first failure occur, normal flow of execution should be interrupted. Okay, so that means this part over here should not be continued. Okay, should not be continued if a fail occur already, which is over here. Okay, I want to refer you to also one particular slide, which you can also review about the JUnit test. Okay, and then I'll talk about other options as well. Okay, so I think that one there is a little bit later on the slides. Yeah, this one here. Yeah, if you look at slide number 33 from the JUnit test lecture, so that's exactly that. You can see we also got try and catch. Also, we got try and catch, and we're using a console tester. And we're saying that you will not be right if you still continues with the tester if you know the first failure already occurred. All right, so that's something that's consistent with what we said in the class. Okay. All right, so that's one here, and then let's now move on. Okay, this one's done. Okay, so this one here. All right, that's nice. Okay, this one here is interesting. Okay, let me put this one side by side with the nested try and catch that we just spoke about. Okay. Okay, let me go back here and then I'll put it right here. Okay, I'll put it right here. Okay, I think it's still readable here. Okay, so now we can now compare, let's say, this one here and also this one over here. Okay, so this one here is a console tester because it uses system and outer print line, and this one here is a JUnit test, and they basically got the same structure over here. You can see the try and catch over here, the outer one, and also we got some inner one. That one there is exactly the same as the inner one and also outer one. And whenever we say we want to fail, also we got also the fail assertion over here. Fail assertion over here. And also you can especially here, right? You can see the fail here is right after this one here. And also when we say system the other print line fail and fail over here. So in terms of the appropriateness for the test, this is also appropriate. However, it's unnecessary. Okay. Appropriate, but unnecessarily complicated, which is okay. We're only talking about being appropriate or not. We are not talking about if you're trying to go for more complicated than necessary. Necessarily complex. Because in order, since we got the specialty about the fail, as soon as the fail really occur, it's going to guarantee, it's going to break the execution flow. That's the definition for the fail assertion. So you will see that there's another later option there is going to somehow not really using the nested try and catch, but it will still work. But this one is working here because that one has the same structure as a console tester. It works, but you just don't need to go that complicated. But the way you actually trace for this tester here will be just the same as before. Okay. Zach, are you okay with this one here? This option here? Just
Yeah, that makes sense.
Okay, very good. Okay, let's just finish that. Wow. Okay, we're almost there. All right, so now we got one more here, and then this will be number 6. Okay. And this one basically is what I was talking about. This one is without any, okay, this one is without any nested try and catch. Okay, so what you can compare would be, okay, let me just say this. Compare this one here versus this one here. All right, this one's an interesting comparison as well. Okay, these two. So the one we just described as inappropriate about the console tester here. We said after the failure actually occurred, we are still going to the next one. So that's inappropriate for the console tester. However, for the JUnit test over here, so as soon as after the first failure, even though we didn't put it in the try and catch, but since the fail is going to occur, it's going to interrupt the rest. So the rest is not going to be executed. All right, let me make that remark over here. Okay, so this one here. So as soon as the first fail occurs, which is over here, the flow is guaranteed to be interrupted. Rather than, you know, if you say system the other print line, it's not going to interrupt, right? It will still go proceed with the normal flow. Is interrupted. Okay, so no need to have nested try and catch. Okay, on the other hand, for this one here, need to have nested try and catch for the console tester. try and catch. All right, over here. Yeah. Okay, good. All right, I think we are approaching the end. Okay, we still got 7 and 8. Okay, this one, let's now take a look. Okay. All right, for number 7 here, let me see this one here. Okay, let me just copy that. Okay, so let's now move to a new page. Give me a moment. I'll just set it up. Okay, let's say this one here. All right. Let's say here. Okay, this one here. If we got the very first method here, and then let's see. Okay, good. Okay, now I see how it works. Okay, let's now talk about method by method. This is the first call. So let's say 2 cases, right? If the exception occur unexpectedly over here, we're gonna fail. That's good. If the exception does not occur, that's good. So we're gonna proceed. So as far as the first method call is concerned, we are good for this test. Let's now take a look at the second method call. Okay, this one here. So that one there is the second call. It's going to be flipped, right? So if some exception occur, there should be a pass. Otherwise, it should be a fail. All right, just keep that in mind. All right, so now if the exception does occur, and we are actually going to not fail. Right, so this part is good. This one, it occurred as expected. In that case, we simply do nothing, so the pass is going to fail. So this case is fine. What's going to be problematic is the next one. But what if we, let's say the exception did not occur? Okay, this is where the test is inappropriate. If the expected some exception did not occur, the test would not fail, which is inappropriate. Okay, so this part here, it should fail, but it would not fail. So how do we fix it? The way to fix it would be, you gotta insert a line over here right after obj.m. If you're able to proceed to there without the exception, you should really put a fail. Right? So this one is missing. Alright, so that's missing. So that's why this option here is also inappropriate. Okay. Alright, I think we got the last option here. Okay, this one here. Okay, this one here, let me, just for completeness, let me also set it up. I can also make some remark. Okay, for this one here, let me put it here. Okay, let me just make sure I got the right one over here. Yeah, that's good. Okay, it's a console tester. As you can see, we got system, the outer print line. All right, so this one here, I can see that right away it's kind of problematic. So the way you can think about it is this. We know that for the first and second calls, they are actually mixed in the same try and catch block. All right. We kind of noted earlier that for the very first and second method call, they actually got flipped expectation. So whenever exception occur, one will be considered as fail, the other one considered as pass. Right? So that's an important insight over there. So now we can put it here. So the first and second calls have the opposite expectation. So this one tells you, let's say if somehow at the runtime the execution flow goes to here. So now this some exception here can be from, for example, let's call this 1 here and call this 2 here. It can be from 1 or 2. Right? You can see here's now is very tricky. So this some exception may be thrown from the first call, in which case we should fail the test. Or if the some exception is thrown from the second call, in that case we should pass the test. So we should either pass or fail, but we don't know. So that's why just saying fail is not right. We simply don't know. So that's why the first and second call should be really somehow be dealt with in different try and catch block, not in the single one. Right? So this is why it's not appropriate. All right, I believe that's all the options we have in this particular question. And Zach, are you okay about this question here?
Oh yeah, it makes sense. Thank you.
Okay, very good. Yeah, no problem. All right, guys. Next question. Let me see. What is the expectation for Tower of Hanoi for our exam? I would say treat it just like maybe any other example that we talk about in class, right? So what would be the expectation for example, all positive and also is sorted, right? So you should really know if I give you something similar, you should be able to solve it. And also you should really, try, for each recursive problem that we spoke about in the class, you should really think about, number one, the problem itself, and also how you can think recursively for the solution, for the different phases that we talk about. And also you should really look at the Java code to see how it works. And then you should also look at the tracing that we did, especially the high level. And also if I ask you something about the call stack tracing, that's also possible. But of course, it may not be as complicated as like a Tower of Hanoi for, like a call stack tracing, or even for is positive. But I think for the call stack tracing, make sure you do the exercise for the Fibonacci example there, right? That's something I even gave you some solution video to follow through. Okay. Does that answer your question from the chat about the Tower of Hanoi? The only thing I said that would not be on the exam would be the runtime analysis for the Tower of Hanoi. That one is only to give you guys some flavor about what you can expect in the next course. For the runtime analysis, that one is not covered. Will concept from lab number 5 cover in detail in the final exam? I would say if I want to relate to any specific detail about, for example, sequence, operator, things like that, I will give you some explicit context in the exam. But I definitely should make sure you complete the study about abstract classes and interfaces. All right? All right, guys, you're welcome. Good. Okay, let me see. Okay, from Jennifer. Okay. Is it enough to do all of the recursion 1 in coding bat? Yes, that's definitely something I recommend. And the example in the class, and should we do more complicated example in recursion 2? I would say if you really have extra time to do a little bit more recursion, of course, the more you prepare, the better. But I would say just doing recursion 1 from coding batch should be enough. If you really don't have extra time, you don't need to go for recursion 2. But I'm just saying it might help, right? But all the example about anything I put on the exam will be something similar to what we covered. Okay. Okay, let me just read the chat. Okay, will the exam have more contents focusing on the later parts of the course, such as inheritance and recursion? Inheritance and recursion are definitely covered in the exam, but I think I should also study the earlier part as well. I wouldn't say which one is going to be more focused. It might turn out maybe some topics might be asked more frequently in the exam, but I think as far as preparation concerned, you should really study more. Everything. That's all I can say. And okay, let's see. Okay, good. So for the lab solution, yes, for that past lab I made available to you guys, I think only focus on the ones on the array. Okay, I can write it on here. Okay, so that one I can clarify. Let me do that. Okay, and I'll continue with the chat reading. So for this particular lab over here, okay, let me see that, and I'll write it down on the paper as well. So okay. So you see, this past lab over here, I think that one they got many exercises there. Only focus on those that uses primitive array. If there's any question there, use let's say array list, for example. That one can try out maybe after beyond the course. It's not going to be covered in the exam. Okay, so let me put it here. So the past lab on recursion only focus on arrays. For array list, not covered. All right, just make it clear to you. All right, that's good. Okay, let me see. That's good, 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 good. Okay, how will we approach studying for abstract classes interfaces? I would say very similar, to how you actually study for inheritance. As I said, abstract classes and interfaces, they are just like a very natural extension to the inheritance topics that we discussed in the lecture. So maybe look at the slides and look at the general principle about what interface is, what abstract class is, and also the two examples there should be very informative about how you can determine, how to manipulate abstract classes. For example, the polygon, triangle, rectangle, and also for the interfaces, how we can have the same two abstract methods like a get x and get y, but somehow you can let one subclass implement that using a polar system, and the other subclass implemented using a Cartesian product, Cartesian system, right? So that's a very nice interface example. Okay, I can see here, go over question 10 on the exam. Yeah, I'll do that in a moment. Okay. Would there be multiple choice questions that are based on the definition concept we learned? There might be. So I think you guys definitely, well, I would say if there are multiple choice questions related to more like a definition, it should be the easy one, right? So I think you definitely should know the like a definition for the important concept. That's for sure. All right.
Professor?
Yeah, go ahead.
Hi. I had a question with the final exam that you posted, like the practice exam.
Yeah, sure.
So one of my questions was that like there were a few questions there, like 6, 7, 8 or so, where it stated that what happens when executing the above Java code.
Yeah, for sure.
So I mean, this is just a general question, not a
Of course.
specific question.
Of course.
It was that what happens when executing. It said that what happens when executing the above Java code.
Yeah.
So when it said that, I thought we were supposed to like describe what it's stating, right? Like example, P1 object is being created, P2, and then it's saying like.
Okay,
P1,
okay, I see what you mean.
Like, and that's what. And then, but when I checked the solution, it just said that we're supposed to write the what's being printed out in the console.
Exactly.
So like, when do we know like?
Okay.
We just need to write on the
Yeah.
console or describe it more.
This is what you can assume. Okay, so when I say, since we say when executing, right, we are more talking about the consequence. We don't really, the way you describe to say, okay, P1 is created, P2 is created, and then we may have to initialize an array, that's more like a tracing. That one is not really about what happened. You can say what happened, but we are more talking about final outcome of what's going to happen. Okay, so when we say what happens in general, it should be the final outcome.
Okay, and if we need to go more in depth, we explicitly say that explain or trace.
You don't really, unless the questions explicitly ask you to explain. For example, let's say the question may say, okay, now this particular line is blank out. I want you to fill it in. And then I may also explicitly ask you to explain maybe why the line of code you supply also works.
Right.
That's possible. But I would say usually, if you got any kind of question like this, okay, similar wording, you simply kind of ask about the final outcome when you try to execute the code. So either there could be some that, like in this case, it will be the output to the console, or maybe when you try to print out this line here, P1 happened to be null. In that case, you would just say a null pointer exception occur, right? Things like that.
Okay.
Yeah, you definitely don't have to go. I would never ask you to say, okay, in line number 1 we got P1 created, in line number 2 we got P2 created. That's not the point. Yeah, for sure.
Okay.
Very nice. Thank you. Okay, so okay, before I go on to, I think one of your questions is about to go over some question there on the written test. On the practice test. I'll go there in a moment. There's also a long question here. Okay, are descendant classes only useful if they have more expectation than their ancestor classes? Okay. Give me one moment. All right, that's a pretty long one. Okay, let me see. All right, since you ask, let me now go there. You're talking about page number 5, right? Give me one moment. I'm just trying to understand the question first. All right, that's the notes. Okay, first of all, the first part. Okay, let me see if I can copy this question here and then I can discuss it. Okay. Give me one moment. Okay, I think that's good. So that's a question from the chat. Let me make it a little bit bigger. Okay, let's now make it a little bigger over here. Okay, I think that's big enough. Okay, good. Okay, let's now just, okay. Are descendant classes only useful if they have more expectation than ancestor classes? I wouldn't say descendant classes are useful, but ancestor classes are not. I think it's more about, in general, compiler will expect more methods to be available on the descendant classes. I wouldn't say useful. Okay, but of course, when you do, for example, downward casting, in general, you can expect more to be called once you get a cast alias, right? So I wouldn't say something about useful or not. Okay, so I wouldn't use this word. Okay, so I would just say that's another way to think about it. Nothing about being useful or not. So we're just saying classes are in different positions in the hierarchy. The lower you are in the hierarchy, the more expectation you can naturally have, right? That's what we are saying. But since you're referring to page number 5, okay, we can take a look. When you cast D, OA, it does not work because the attribute is not declared in class C. Okay? Let's now see D and OA. Okay, I presume the OA over here. Okay, so the assumption is, so A, we have some dynamic type C. All right. So here, so the assumption is, so here we got some cast over here, and then we got OA, right? So guys, when you read the notes, I'm just gonna summarize the context over here. Okay, so here we assume that the dynamic type for OA is actually C. All right, and then we have some inheritance hierarchy here. I'm gonna redraw that quickly. Okay, I want to make it as self-contained as possible, right? So A here, and then we got B here, we got C here, we got D here. Okay, I'll switch back. All right, like here. All right, so when we try to do this cast over here, oh, let me do one more thing, right? So when you look at that, OA, object A, has the static type. Let me just double check. It has the static type A. Okay, that's good, just to be sure. So when you look at OA, it has the static type, that's A, and dynamic type C. So you can think about the static type is A over here, and the dynamic type is actually C. Okay, so we got static type, and we got dynamic type over here. All right, so when you do this cast over here, indeed, you're basically doing downward casting from A down to D. So when you were in A over here, what you can expect will be only from this ancestor. But when you downcast to D, you will be able to expect more once you get an alias. For example, let's say here, if you got D and OA dot something, right? So potentially what you can put over here as a method, the list of method will be what's accumulated at this level over here because we got a type D, right? On the other hand, if you didn't have the typecast, you got OA. OA was declared to be static type A. So what you can, if you say OA dot something here, so range of methods you can expect will be only those in A, right? That's something to clarify first. And then, of course, in this case, you're going to have a class cast exception because over here you got D here, right? So D is a cast type. So one thing we can note right away is, so you can see this is the dynamic type, this is the cast type. In that way, you're going to have the class cast exception. Because C, the dynamic type, cannot fulfill the expectation of the cast type D. All right. Does that kind of answer your question from the chat about this page over here? So did I answer your question? Okay. Okay, again, so this is something we explained in the class. It doesn't really matter if at the moment C and D have exactly the same attributes and methods, because in the long run, it's most likely the case that D is going to add more attributes and methods. Right? That's something we emphasize quite a few times in the class. As long as you are lower in the hierarchy, doesn't matter if at the moment you got just the same classes, just the same attributes and methods compared with your ancestor. Doesn't really matter. It's just in the long run. Most likely, you're going to add more and more attribute and methods to the descending classes. All right, awesome. That's an important point, actually, right? That might be something I can make it like a standalone slide. Maybe in the next time I teach 2030. I think you guys may have some common confusion about this. All right, but guys, let me recap again. That's very important from your classmate. Okay, so let's say even though at the moment we say that we're going to get a class cast exception in this case because the D here, that's a cast type, is actually lower than the dynamic type. So so Java runtime is going to think D is going to have more expectation than C, and because C cannot fulfill D, so we're going to get class cast exception. So this is going to happen even if at the moment you got just the same methods declared in C and D. Let's say there's no extra methods accumulated in D. Even if that's the case, you will still get class cast exception. The idea is, in the long run, it's most likely the case that you're going to add more expectation to the methods. So that's something that's assumed. All right. All right. I think there is one demand over here from Joseph to go over question 10. Okay, on the practice question. Yeah, I'll do that. Other than that, I think I answer everything on the chat. In case I missed you, please let me know. Okay, let's now look at question 10. Yeah, we can do that. Over here. All right. Right, so here, of course, you got a keyword interface, right? And also, well, I would say don't be too terrified, about the interfaces or abstract classes. The way you build the inheritance hierarchy or the way you figure out variable substitution will just be the same. That's why I said interfaces, abstract classes are some topics you can definitely study and understand on your own, given we have already got a discussion about inheritance in general, right? Okay, this one let's talk about quickly. So we got interface I, okay, that's always on top. And then we got two subclasses. We got A here, we got B here. All right. So we got A here, and we got B here. All right, pretty simple hierarchy, right? You can think about I here is a little bit like a student, and this one like a resident student, this like a non-resident student, a little bit like, okay? And we try to implement the methods differently. Let's say in A over here, we're going to print out. So for MI, you can think about that one there is more like an unimplemented. I'll put a star. And then for A over here is going to have some version, right? So for A here is going to implement the MI, is going to print out A.MI. Whereas for B here is going to implement a different version here. Also MI is implemented. I wouldn't say overridden, because you only say overridden if the method you're trying to override already is implemented in the superclass. But in this case, in the interface, it's not really implemented. I wouldn't say override. Okay. So now MI is going to implement the method differently. So now it's going to print out B.MI. Right, so that's something you can sketch right away, you know, once you have seen the 3 declarations over here. And then we got collector. All right, so this collector is a little bit like the polymorphic array that we spoke about, you know, in the lecture. But let's just dive directly to the question. So line number 7, all right, over here. Okay, it's basically talk about this variable assignment specifically, all right? So when you want to determine if something will compile, you only consider static type, right? So you're going to look at the static type for A. That one there was declared as A, right? It's the parameter, right? That's something I can figure out right away. And what about the static type for this array at a particular index? So you can see the array was declared exactly over here, right? So that's also something we set in the class. That means every element in the array at at index I, assuming that I is valid, has the static type A. All right. So this one here has the static type A. So here you got some variable substitution, and the rule is this one has the static type that's a descending class of the static type of this. So this is the case because A is a descending class of itself. So if you look at the answer, it's explaining exactly that. So Joseph, are you okay with part A?
Yes, thank you. That makes sense.
No problem. Okay, let's look at part B. Okay, we'll look at every part since now you want to talk about it. Okay, and then explain if the method called this one here is going to compile. Again, we're going to look at static type. Okay, so for this one here, let's look at line number 12 and this one here. All right, in order to determine if the method should really compile, okay, first of all, we know that ASI has the static type. Static type is A. All you want to ask yourself would be whether MI is declared at A. Is MI part of the expectation for A? And if you look at A here, indeed, because A here has MI. That's kind of a being implementing the one that's from the interface. So indeed, all right. So you will see the answer something like, you can think about MI is part of the expectation of the static type of ASI. And we will figure out that one is just A. All right, that one is also not too bad. And then we want to look at line number 3, okay, of the tester. So this one here, let's look at line number 3. Line number 3 is over here. Well, again, about compilation. All right, this one here is a bit tricky, right? Before we talk about abstract classes or interfaces, right? Whenever you want to have, let's say, a static type and also you got some dynamic type, as long as this class name over here is a descending class of that, it will compile. However, that's something you want to watch out for. When we talk about abstract classes or interfaces, because they got at least some methods that cannot be, that are not implemented, so they cannot be the dynamic type. That's something you will see when you study the actual abstract classes interfaces. But I just want to remind you. Okay, so here you want to say because interface is not fully implemented, it cannot be, it cannot be a dynamic type. So that's why this one here, no, it does not compile. Just watch out. All right. If the class you're talking about here is neither an abstract class nor an interface, normally that will work if you just got the same class over here. All right, Joseph, go ahead. Question.
I was wondering if we had an object that had its static type as I, but the dynamic type is A.
That will work.
Would we have to would we have to cast to call a method in A that does not?
Okay. I like it. Okay, that's good. Okay, I'll make it explicit here. Very good. So let's say this. Okay, let's say I, and then let's say obj equals new a. Okay, that's exactly what you say. And this one here is good because a is a subclass of I, right? A is a subclass of I. That's good. So now let's talk about different scenario. If I just say obj dot mi, in this case, I do not need a cast because mi is already declared in the static type of I, a static type of obj, which is I. And we got mi exactly here. And it's guaranteed that mi is implemented in the dynamic type. In this case, that'll be a. All right. So this one here, I can just make a notes. This one compiles. Sorry, just write properly. Compiles. And also the version in A corresponding to the dynamic type is called. All right, and then back to your question there. Let's say as time goes by, right? We can always expect something to be added to the subclasses. Let's say we decide in class A, not only that we have already implemented mi, we got another method. Let's call it ma. All right, let's say. So that's a new method which only exists in A, but not I. Now, if I say obj dot na, apparently this one here is not going to compile, which you correctly said, because the ma over here is not declared, it's not part of the expectation of the static type of obj, which is I. As you can see, I here does not really have ma. So what we can do is we can do a cast, as you said. So if you try something like this, if I try to cast ma, I try to cast obj. Let me do an anonymous cast. I can cast obj into downcast into a, and then make sure you wrap it around in the parentheses, and then I can say ma. So that will work. All right. So this will be some extra example for you guys to also think about. All right, these 4 lines. Okay, that's good. Okay, so let me just look at the chat over here. Okay, we're good. Okay, let's now talk about this question here. Okay, so the console output from line number 7. Okay, so line number 7. So we got line number 7 here, which is over here. All right. Okay, we may need to visualize a bit over here. So we got a collector here, C. Okay, so C is a collector. Okay, I'll put it here. And you can see for collector, we actually got AS and BS, basically 2 arrays. That's for the collector. Okay, over here, and then we have that. And then that would be collector objects. And then you have AS and also BS. Okay, 2 arrays over here. And also we got 2 counters over here, right? So we got, I'll put it here, number of A's and number of B's. Okay, I'll put them aside, but if you want to include them as part of the box, you can do that as well, but let me not do that. So during the exam, we are not going to grade your intermediate work about visualizing objects, so you can definitely visualize object in whatever way that's going to work the best for you. Okay, so for now, I'm just going to put these 2 counters aside. Okay, and then we're going to initialize the array. Each one of them is going to be of size 10. All right, over here and over here. Okay, I'll just put a few. 0, 1 all the way to 9, and also 0, 1 all the way to 9. And it would be also useful to also include the static type A and B. All right, I'll just put A here and also B here. Okay, I'll put it aside. All right, and that's about tracing this part over here, and then we got 2 objects, A and B, right? So let me put the object here. We got A, which has the dynamic type A, And also we got B, which has the dynamic type B. Right, you can see that one there. All right, and we are just going to add B and also add A. All right, and you guys can review very quickly. So does this method called compile, right? In order for that to compile, the static type for the argument here, which is B over here, is that a descending class of the corresponding parameter, which is B over here, right? So that one works. And you guys can review what we spoke about the student management system in the lecture, right? That one there, we got even more example there. So whenever you say add B, is going to add into the B's array. And whenever you say add A, is going to add A into the AS array. Okay, it's different. So let's say after this line over here, we're going to add the B into the B's array over here. And that one there, of course, is going to increment the counter here from 0 to 1. Whereas, so now when you say C dot add A, it's actually going to add that into 0 over here, right? Also, you're going to increment this counter over here from 0 to 1, right? And then we're going to call all right? And let's now look at that method there, right? Call all is over here. Okay, let's now take a look. That one there is actually not too bad. It simply will just go over the number of A's and number of B's. Basically, we go over this array first, and then we go over this array. So going over this array is done by this first for loop. And then we go over the second array B's using the second for loop. And then for every one of them, we're simply going to call mi. And remember, mi was declared at the top level for the interface. And depending on what the dynamic type is, we're going to call the corresponding version due to dynamic binding. All right. So now let's now talk about this part here, right? Let me annotate a little bit more. So C dot call all, right? So think about loop number 1 and loop number 2. All right. So loop number 1 and loop number 2. When we execute loop number 1 over here, we're going to have only one iteration because the counter over here is only 1. And similarly, for the second loop, there's only going to be only one iteration as well. And for the only iteration, it will boil down into AS at index 0, and then that will be referring to A here, and then call mi. And that one there is going to invoke the version of mi in A, right? And that one there is going to be A.mi. All right. That one there is going to be A.mi. And then when you go to, when you actually go to the second loop in call all, that one there is going to say BS at index 0 for the first iteration .mi. So BS at index 0 is referring to this object here with the dynamic type B. So it's going to invoke the B version of mi, which is going to print B.mi. All right, so that one there is going to print out B.mi. All right, so that's of course, if you look at the answer over there, it also explains in what I just described. You can look at that too. So Joseph, are you okay about this one here? Part D.
Yes, this one makes sense.
Okay, very good. Okay, now we get to the final part over here. All right, so let's now read it together. So the collector class does not really make use of polymorphism, right? So if you got, well, you guys kind of asked me whether there could be some definition question. If I were to put definition question, the very likely one could be polymorphism, right? But I'm not saying there will be, but it's likely, right? So polymorphism over here, you guys can also refer to the definition, but informally, that means given some static type. So let's say if you declare X and then some obj, right? So based on this static type X, the dynamic types can be any of the static type X's descending classes. Okay, descendants. That's an informal reminder, but you should really look at the slide to see polymorphism. Okay, which results from the fact that the A and B, okay, implements a complement. Okay, so polymorphism here is really natural consequence when you got subclasses and some common interface. So in this case, in this example, you got interface I at the top, you got A and B. That means if you declare something of static type I, dynamically it could be either A or B. That's polymorphism, right? But somehow the collector class does not really make use of it because it kind of separate between A and B, whereas it could have just combined these two into just I, a single array, in which case the dynamic type can either be A or B, right? So that's exactly what we kind of spoke about in the student management system class, all right? All right, so what we're going to do is we want to make sure there's only one array attributes and only one loop. Okay, I can sketch very quickly, but you guys can also look at solution. Let me show the solution right away, right? So I don't need to sketch too much. So if you go to that solution there, let's now take a look. So we will see exam here. Okay, let's look at that final question there. In some way, this is very similar to the student management system when we talk about polymorphic array. All right, so you can see here under the collector class, here, we only got one single array, and the static type over here is I at the top of the hierarchy, the interface. And then we try to initialize it. That's fine, but now we only got one add method, and the parameter type is the top one. Because of polymorphism, the objects we store into the array can be anything that's a descendant of I. That's why in this diagram here, you can see we got both A and B, right? A and B. All right, you can definitely do that. And also for the for loop, since you got a single array, you only need a single loop. In that case, whenever you say is at index I.mi, because polymorphism ISI here dynamically can either be A or B, right? The descendant classes of the interface. Either A or B. In that way, dynamic binding is going to make sure you call either this version here or this version here, depending on where you are. Final sketch over here, and then we can take a look at other questions. So once this is done, you're going to have, so IS is the polymorphic array. It's going to have certain length over here. Okay. So this one is declared as I array. All right, so that means every element has a static type I. All right, and then you got index 0, index 1. They have the static type I. But by using the code structure in the solution, you will be able to actually build, for example, insert an object here of dynamic type maybe A, and insert another object here of dynamic type B. So you can see statically, every element has a static type I. That one wouldn't change because that's how you declare the array. But dynamically, it can be A or B, any of the descendant classes of I. All right. All right, Joseph, any follow-up for that?
The only question that I was wondering was, in the original collector class, the size of A was 10 and the size of B was 10. When we're making our new collector class that uses polymorphism, how much does this size of
it's a good question, but matter? You know, to be honest with you, I think the size may not be the focus point over here, because in some way when we say 10 and 10, just large enough, so we got enough storage. You can make it 20, that'll be correct, but if you just make it 10, that's fine too. So the main point here, the focus will be mainly about the types.
Okay, thank you.
All right, that's good. What if A is an abstract class? Okay, that's from Jennifer there. All right, so let's say we got I here, and then the problem is A here, that's interesting. When you actually implement, this is something I haven't really tried before, but I can feel free to try. This is a little bit complicated. So let's say here, A here, if you say A here is trying to implement the interface, I believe the rule is whenever you want to implement an interface, you must implement everything, every method in the interface. In that way, it's going to make the class not abstract. I believe that's the case. Okay, just to mention that. That's good. Okay, from Brian, can I go over question 9 and then part G? Okay, let's now see this one here. Okay, let's now look at part G. All right, so explain if line number 8 compiles. Okay, so let's now look at line number 8. Okay, over here. Okay, whether that will compile, and then we're gonna, if yes, we're gonna write down. If no, we want to suggest a fix. Okay, good. Okay, we're talking about line number 8 for part G. All right, so let's now build from scratch very quickly. And of course, if there's any line that does not compile previously, we just ignore them. Right, that's what the question says. Okay, let's now build the inheritance very quickly. So we got A extends B, and also B extends C. And we got C here, and C here, we got some method. You know what, let me just draw a little bit better. So we got A extends B, B extends C. In C here, we got a method here, BM. And then it's going to print out C.BM. And then we got D extends C. And over here, we got CM. And then we print out D.CM. And also we got F extends D. F extends D, and then we got two methods here. So we got BM, also we got EM. So F.BM and also F.EM. Alright, so finally we got also E extends F. And then we got here DM and also E.DM. Alright, so that's the hierarchy we have, right? And then let's now do things from line number 1 to line number 8, right? If the line compiles, we're gonna visualize it. If it doesn't compile, we ignore that. Okay. So here we got C. So the first object here, let's say C and D. So this one will not compile because C over here is not a descendant class of D, right? So conceptually, I can just delete it. Okay, I don't need to worry about it. And then we got C here and D. That makes sense, right? Because you can see D here is a descendant class of C. So what I will do is I'm going to visualize that one there. So I'm going to say D2 is pointing to an object of type D. And then the static type over there is C. All right. And this one here, I'll just mention that anyway. So D2.BM. So D2 here is declared as static type C. Does C have BM? C does have BM. So it's going to print out C.BM. So I believe one of the earlier questions asked you about it, but I just went over that. And also line number 4. Okay, now we're going to say E and D. E and D. So that's good. So that one is going to compile because E here is a descendant class of D. All right. So that one there, we're going to visualize that as well. So I'm going to have also E1 pointing to some E objects. And then static type is D. All right. So this one also compiles. Okay, this one compiles, this one compiles. And for line number 5, so in order for the variable substitution to compile, so E1 is D, which is over here. And we're going to assign that into D2, which is C over here. So that's fine because D is a descendant class of C. And once we have done that, we're going to reassign D2 into E1. Right? So that's what we'll do for this one here. And then when you say now D2.BM, it will only compile if BM is declared in the static type of D2, which is C. Does C have BM? So C here have BM? Yes, indeed. So it's gonna. So this one I can just mention. Okay, this one here compiles because the static type of D2, which is C, declares BM. Right? You can see exactly here. What about dynamically? Dynamically, if you try to call D2.BM, because the dynamic type is actually E, so it's going to call the E version of BM. All right, this one is interesting. Okay, I'll just mention that even though that was not really asked. Okay, so this one here at the runtime. And this one here will be similar to what we spoke about in the for the equals method, in which case you gotta find the overridden version of the closest ancestor. All right. So here, when you say D2.BM, we already talked about why it compiles. And if you look at the D2, is currently pointing to E objects. Dynamic type is E. So if you look at E here, E itself does not have the overridden version for BM. So you go up one level, and then you can see the BM over here. That's the closest ancestor for F. So that's why it's gonna call this version here. All right. Call the overridden version in the closest ancestor. In this case, it will be F. All right, and then it's going to actually print out F.BM. And then F.BM. All right, so that's for line number 6. Okay. And then we try this one here. We say here E1 is assigned to F. So E1 has the static type D. So is D a descendant class of F? No, it is not. Right? So this one will not compile. Right? Let me say it again. So we are doing this variable assignment here. In order for this to work, the static type of E1, which is D, which is over here, must be a descendant class of the static type of F. It is not. D is not a descendant class of F, so it's not going to work. So this is not going to compile, so I'm also going to delete it. Okay, so let me delete it. That one doesn't compile. Okay. So what we do is let's now execute line number 8. So when we say E1 dot EM, all right. So E1 that E1 has the static type D. Does D have EM? No, D does not have EM. You can see EM was only declared over here in A. Right? Okay, let me now explain that one there. Okay, line number 8 over here. So that one there, let's now analyze that more carefully. Okay, so now for line number 8. When you say E1 dot EM, first of all, you know for E1 there, it was declared to have the static type D. Alright, goes back here. Static type is D. And you want to look at D here in the hierarchy. Does it have, or does itself declare, or is somehow accumulated from its ancestor about the method EM? No, it's not. You can see its expectation will only be CM and also BM. There's no EM. EM only was declared in this particular sibling class. That's in another branch. All right. So that's why this is not going to compile. Not compile because EM is not declared in E1's it's not declared in E1 static type or its ancestor. It's simply not accumulated. All right, so this error here is also very important. All right, so I'll just highlight it over here. All right, so at least we know it doesn't compile. And the question was suggesting, let's see, if no, suggest a fix using typecasting. Okay, let's see what we can do. Well, you can see here the static type is D. And then the EM is a method that only exists in A, right? So that's something we want to cast into. All right. So if we want to go from D to A, so what the exercise that we did in the class, there's a way to do it. Basically, you can try to upcast and then downcast, right? If you try that, it's going to work. Compilation, at least. All right. So for that one there, okay, I'm gonna continue. So this doesn't compile. That's part number 1. And then I'm gonna talk about part number 2 over here. What we can do is we can try to cast EM, which has the static type. Sorry, not EM. I mean E1. Okay, the E1 over here. We can try to cast the E1, which has a static type D. First of all, we upcast to C, and then we can downcast into A. This will compile, and then once we have got that, you can now try to put the parentheses around, and this one here, if I say dot .em, is going to compile. Okay, compilation wise it works. But what we should really watch out for is, so here you can see there are 2 typecasts. This is cast number 1, and you can see this one here is cast number 2. Alright, so we got cast number 1 over here and cast number 2 over here. Each cast, we have to somehow analyze whether or not we're going to run into class cast exception. And the dynamic type for E1 is actually E. Right, you can see dynamic type here is actually E.
Excuse me, Professor?
Yeah, go ahead.
I think EM is only defined in class F, not A.
So EM, not A. Did I copy something wrong? Maybe I did.
It's in class F.
EM is F. Oh, I copied that wrong. Okay, sure. Let me review that quickly. Thank you for letting me know. So let me see A here. Okay, I think for A, let me see here. Oh, I just read it wrong. Sorry. So when I look at this one here, I was thinking yeah, it should be this way here. Okay, that's correct. Okay, so just be careful. Okay, let's revisit this very quickly. Okay, so now if I look at this one again, E1 has a static type D, and D we know that does not have the EM, so that one still applies, right? And now if we want to do casting, okay, it's actually turned out to be, I was thinking, too complicated. We don't need to do upward and downward, only this part here. All right, this one is wrong. I'm gonna erase this part over here. Okay, so what I will do is I'm going to put number 2 over here. So it doesn't compile for the same for the reason as I said. But now if we want to make a compile, because we know that static type is actually D, but it only exists in F. So what we should do is we should really downcast into F. All right. So let's just be sure. So EM is actually in EM. Let me just make sure. Okay. EM is in D. Let me just make sure I got it right. So I got BM here, and also I got EM here. That's great. I got BN here, and also that shouldn't be. Sorry, I'm just trying to think. F here, and then we got Bn here, we got em here. Okay, that's great. That's great. Okay, for number 2 here, let's now finish that. I just need to do downcast from D down to F. Okay, and let's try that. So what we need to do is we're gonna do a downcast. So what I will do is I'm going to downcast E1 over here. And then currently it's D, but I want to downcast that into F. And once I have done that over here, I will be able to invoke that method, which is EM. All right, sorry for the confusion from my end. So when you do on the exam, make sure you kind of, I even drew the diagram correctly, but somehow I was interpreting this method to belonging to A rather than F. That's my mistake from my part. Just make sure you don't make the same mistake. And in this case, we want to downcast from the static type of E1, which is D, down to the class that will support EM. So we can make the method call. But apparently we're going to run into, we are going to see, are we going to run into class cast exception, right? That's the next question. Since we are casting into F, for example, over here, so we will be okay because the dynamic type is actually E. So we are not going to run into class cast exception, right? As long as the dynamic type E over here can satisfy the expectation of F because it's a descendant, so we are okay. So there's no class cast exception. And then, so for this one here, it's going to return, it's going to call the version that's actually that's overridden in E for the EM. But because E has no EM, so we're going to use the F.EM. That's the version. All right, that's the closest ancestor. Okay, and that one there is going to call F.EM. All right, so Brian, if you're still here, you can ask for this particular one. Is it okay? Can I answer your question? In case you're still here. Okay, which part are you confused? Which part? You thought the call to the E constructor implicitly implied dynamic type E. Yeah, dynamic type is E, that's true, over here. So that's why the version that's actually defined in E should be called. But E here has no EM, right? We're trying to call EM. But EM is only overridden, the closest one will be the EM in F. So that's why this version here will be called. Does that kind of clarify your confusion, or you're still confused? No, this line doesn't compile. If you only got, okay, if you only, so for this line over here, line number 8 originally is only E1.EM, right? As far as compilation is concerned, we will need to consider the static type for E1, which is D. But D over here has not declared EM, so that's why it will not compile. Since it does not compile, we can try maybe downcast. So we try to downcast D to the F that declares EM. So that's the downcast we have over here. And once we downcast, there will be no class cast exception because the actual dynamic type for E1 is actually E. And E is a descendant class of the class type F. So there's no class cast exception. So when you invoke this method here for EM, it's going to look for the closest ancestor overridden version. In this case, that'll be in F. You okay? Or still confused? Can you generalize to say that if the method is not present in the static type or dynamic. No, no. Whenever you talk about compilation, you only talk about static type. It's only when you talk about what's gonna happen at the runtime, and then you will consider the dynamic type to see which version of the method that's being called. That one should be clear. All right, maybe you're just missing the most important principle. So, all right, good. All right, guys, just before I leave this question here, all right, and sorry about it in the middle for a few minutes, I was confusing myself about these methods should belong to A. No, that's not the case, right? It should belong to F. Apart from that, everything I said is still consistent with what we said in the class. Let me recap very quickly. For this line here, line number 8, all right? Line number 8 does not compile for the very simple reason. The static type for the context object here for E1 was declared as D, and D itself does not accumulate the expectation of EM, because EM was only declared in its descendant classes. So it's not part of the expectation of D. So that's why the original line here does not compile. And the way to make a compile in this case is just make a downward cast. So we'll downward cast from D down to F. So that's what I did over here, right? We spoke about anonymous cast in the course. Well, I mean, in the typecast lecture. Once you do the downward cast, this one here is going to create an alias of static type F. So that's why we can now call it part of its expectation, which will be EM. So once we execute this at the runtime, we'll only look at the dynamic type. So at the runtime, dynamic type for E1 is E. So that means the version of EM from E is going to be called. E itself does not explicitly override EM. So we got to look for the EM in the closest ancestor. So we go one level up over here. So now in the ancestor F over here, it does have the overridden version, or it has one version there. That's EM. So that's going to print out F.EM. So that's why. All right, so I think some complication over here, right? But it's not too bad. Can I cast to E? Yes, I can cast to E as well. Yes, indeed. So here, I think, I'm not sure if I mentioned that in the answer. So here, if you try to cast to F, certainly it's going to work because EM is defining F. But if you cast that into E, over here is also guaranteed E statically accumulates the EM anyway. So it's also fine. So in this case, you can downward cast to either F or E. So you got two options here. Either way will be correct. Okay, does the typecasting only change the static type? No. Typecasting doesn't change the static type. It doesn't change anything about the original variable. When you say, I want to do the casting over here, the static type for E1 never changes. Never, ever. What we are doing is, we are basically creating an alias over here that's of static type F. All right, just want to be, you're gonna want to make sure you revisit that part of the lecture, right? We never modify the static type by typecasting. All right. All right, guys, any other questions? Any follow-up? Or if you want me to clarify more, I can potentially stay for 10 more minutes if you got more questions. About abstract classes. Yes, go ahead. What about it? Okay, Jennifer, I'm presuming you're typing. Okay. By definition, they need at least... Okay. I think in Java, strictly... Okay, when in the exam, you can go by the definition, which would be a little bit simpler. So for our definition, at least for now, you can think about whenever you're trying to create an abstract class, it's because you want to have at least one method that's actually abstract. Because conceptually, if you just want every method to be not abstract, in that case, a regular class will do, right? But for our definition, yes, you can definitely say if you got at least one method that's not that's unimplemented, it will be abstract. Yes, that's correct. Jennifer, is that it? You just want to confirm this definition, right? I presume.
No, I had something else.
Go ahead.
So,
Okay, that'll be
asking
easier.
this
Yeah, go ahead.
because-
What's your question? Yeah.
I was asking this because if an abstract class like implements an interface, right, then it's forced to implement all of its
Right.
methods.
Right.
I just tested it out right now. It's not
Yeah.
going to let me have an unimplemented method, not even a new one. So
That's
that
correct.
kind of defeats the purpose of making it abstract. But it doesn't give me an error for
Yes,
calling it
exactly.
abstract.
So yeah, that's yeah. Again, because you guys are first introduced to the idea about abstract classes, so we are going to stick to the following notion. If you want to have at least one method that's unimplemented in your class, then you should declare that as abstract. That's for sure clear. Okay. So now you're talking about something that's a little bit more advanced, which for this particular scenario, I can tell you is not covered in the exam. That's a little bit more advanced. Okay. So over here, let's say I have some interface over here. Presumably, I got maybe M1, M2. They're simply unimplemented. I'll just say star here to say they're unimplemented. And then you say you want to have some abstract class, let's say AC, right? So this is some abstract class. So here, scenario, I wouldn't even dive into the details about it. This one is a little bit tricky, okay? But at least following what you learned in the slides for abstract classes and interfaces, here you will be forced to really implement M1 and M2. They must be implemented. Right? For this particular scenario, we are not going to ask you about it in the exam, which means whenever you're trying to implement a particular interface, you will just have regular classes implementing the interface, in which case they will be forced to implement everything. We're not going to test you on a scenario where you got some abstract class that's going to implement interface. This is something we are not going to cover in this course. Maybe in 2101, when we implement maybe the tree, then we might run into some scenario where you have to do this one here. Because once you got the abstract class over here, you may have maybe further abstract classes down there, or maybe some regular classes even underneath it. But that'll be too complicated for now. So that's why I said in this scenario here, if you got some subclass of the interface that's abstract, we don't really test you on that. So we can skip it for now, just for this scenario.
Okay, makes sense. Thank you.
Okay, very good. Okay, okay, how much the multiple choice section is worth compared with the written section in the test? I wouldn't say for now. I do know the answer, but but if I say it, I gotta tell you the truth, but I'll choose not to say. But I can tell you that in the exam, you only got some multiple choice, but mostly it will be written questions. That's something I said earlier in the class. So there will be some multiple choice, yes, but mostly it will be written questions. All right, good. Thank you. Okay, guys, any other questions? How many recursion question will there be? Okay, recursion specifically. I wouldn't give you the exact number, but you got more than one. How about that? Recursion related, you got more than one. But as I said, for the recursion question there, if you actually go over all the example that we cover and also the assigned recommended study, it should be okay. So the ones I cover in the exam are basically something we cover already in the course, right? Jennifer, go ahead.
I have a question regarding recursion. There was this problem that I was doing in coding that, right?
Coding bat 1?
The last one. Yeah, and coding bat recursion 1.
We can potentially take a quick look.
Yeah. I was wondering about like the intuition behind it, I guess.
Sure. This one here?
Let's see. Yeah, that one.
String dist.
Just
Give me a moment.
So this one?
Yeah. Giving a string and also non-empty string. Okay. Compute recursively the largest substring which starts and ends. Okay. I think the intuition would be, because it's, for example, over here, let's see.
Yeah, the way that I was thinking about it was like looking for the substring on both sides.
Yeah.
And if you like, yeah, basically like if you find that both substrings are from both sides are the same, then you give the length. Like
this one is definitely on the more challenging side. Okay, how about this? Jennifer, since you asked about more about like an intuition behind the recursive thinking, am I right? Okay, how about this? Let me write this down, and then I will make an e-class announcement to tell everybody about some hints about implementing this. I'll write down more properly, and then I'll do that. Okay, good. For me, I'll make a notes. Okay, and then you guys can expect maybe some e-class announcement from me pretty soon. I'll make it tonight, right? I know your exam is on Sunday. Okay, I'll put it here. Maybe not a solution, but I'll give you guys some hints about how to implement this one. Okay, I'll put it here. So, hints on recursive thinking to come. All right, I'll do that. Emma, go ahead.
Hi, Professor. So
Hi.
Going back to question 10E in the practice questions.
Sure. 10E. Okay, let me go there.
Yeah.
Of course. Yeah, go ahead. What about it?
To code the solution, would I be able to keep the original two methods, the add A and add B, and then just cast up the
I see what you mean.
element,
Okay.
adding it to the array?
Let me see.
Or would that not work?
Okay, let me see. Okay, so I would suggest, let me first of all open up the solution, and then we'll go from there. Okay, so this one here, okay, okay. So let's get the original one here. Let me just make a add A and add B. Yeah, I see what you mean. Let me just copy this. I'll discuss that. So now I'll paste it over here. Okay. Okay. So this is the original version there. And let's say this. So since now in the revised version, we don't have A's and B's separately anymore. So what we're going to have is, let's say this. So let me just follow what Emma was suggesting. Let's say we got I array IS. Okay, so that's the declaration over here. Okay, of course, this one here, we already got it in the solution. So we got, so now here for add A and add B. So if we got IS and also IS. So let's now, first of all, think about whether this will compile or not. Okay, this one here, you can see A here, static type is A. Here, IS, static type is actually I. So A is a subclass of I. So this one here, you don't need to change anything. And over here, if you say add B over here, so B static type is B. And then B is a subclass of static type of IS, which is I. And so these two, you can definitely still keep them, for sure. In addition to it, the reason that the answer is really suggesting the minimum possible. So if you get, for example, add I over here, if I simply say I here, and then I here, all right? So now this one here is going to be IS, okay, number of I's, and then equals I, number of I's plus plus. But now if you take a look at this one here, this assignment here. So I was declared as static type I. IS declared to be static type I. So I is a descending class of itself. So this one is going to compile. And this single method here should really do the trick for building the polymorphic array. Let's now see some quick example. So let's say I got my collector object C already. So if I say C dot, let's say, let me just play with anonymous object. Okay, that'll be a little bit quicker. So if I say C dot add I, and then I can have another one say C dot add I. Of course, you can try yourself to really pass, maybe creating some other objects beforehand and pass over here as argument. But I'll show you something a little bit interesting. I'm going to use anonymous objects. So new A and also new B. So both are going to work. So this one is going to work because now A over here is a descendant class of the parameter type I. And also B here is also going to be a descendant class of I, right? So what's going to happen is you're going to execute 1 and 2. So the array that's polymorphic for IS. So now index 0, index 1, the static type will just be I as declared, right? I here and I here. So when I add in, the first A object here is going to be put here. So A. And then B here is going to be here. So we still get a polymorphic array. So having a single method here will be enough. But if you try to add A and add B, it can still work. Right? But you mentioned typecast. You don't need a typecast for the reason that here A is already a subclass of IS, which is I. You don't need a typecast. Does it make sense to you?
Yeah, thank you.
Very good. Good question. I think so guys, this will be also some nice extension for you to think about, right? Why these two will still work. Okay. All right, how about final call? If you guys got any more questions. All right. All right, if no, then thank you for coming and staying. And then I think that'll be it. I'll release the recording pretty soon. And then the recursion question that's asked by Jennifer, I'll also give you guys more hints about implementing that one. You guys are welcome. And then, as I said, my final words before the Sunday's exam. Just go back to the E-class announcement and then look at that. In the beginning, I show you some E-class announcement. I'll show you directly, right? It's just a general tip about how you should really tackle the exam question. Even though you got 3 hours, but there will be questions that you got to answer, one by one. So look at the cover page over there. Maybe take a quick look at the tips over here, right? Just think about you're gonna feel nervous and sometimes can be a little bit frustrated if you don't have the immediate clues about the question. But you're just gonna maybe skip the question temporarily and then go back there later, right? So you want to maybe answer a question you can answer right away first and build a momentum. All right, look at the tips. I hope that will help. All right, guys, you're welcome. Thank you so much. And then good luck. And you still got tomorrow. And I will see you guys on Sunday. All right. Take care. Okay, I'll see you later. Bye-bye.